This is Mr. Anderson for Kellogg Community College. We'll be spending our next video here talking about some of the properties of right triangles, and we will also take a look at the start of solving for missing sides and angles with right triangles as well. So this video is broken into two parts. The first part is dealing with some expressions and finding exact values, but more or less knowing the formulas that go along with these. Now I'm going to create a little rectangle here, and inside this rectangle is going to be three equivalent expressions here. Now from the previous side, on the true and false, I asked you if the sine is 52 degrees, what would the cosine be? The cosine would be what degrees? And the answer to that problem is 38 degrees. Because on the right triangle, you can see that from the perspective of the 52 degree angle, the sine would be the same as the cosine would be from the perspective of the 38 degree angle. And that was explained a little bit on the previous video, but now we're actually going to use these expressions here, that the sine of theta is equal to the cosine of 90 minus theta. The secant of theta is equal to the cosecant of 90 minus theta. And then finally, the tangent of theta is equal to the cotangent of 90 minus theta. So, if we look at problem number 9, which is the tangent of 12 degrees minus the cotangent of 78 degrees, the tangent is equal to the cotangent of 90 minus 12 degrees, or this would be equivalent to cotangent of 78 degrees. And the cotangent of 78 degrees minus the cotangent of 78 degrees is 0. Now in problem number 10, the cosine of 40 over the cosine of 50, well, we can convert either cosine or sine into the other term by using this expression here. So let's look at cosine for a moment. I can turn the cosine of 40 into the sine of 50 degrees. And so the sine of 50 degrees divided by the sine of 50 degrees is 1. For problem number 11, we have to remind ourselves a little bit about what is 1 plus tangent squared theta equal to. And that answer there is secant squared theta. That is from this is a derivation of one of our Pythagorean theorem identities of the unit circle. So this whole thing gets changed to the secant of 5 degrees squared. And we can turn cosecant squared into the secant of 5 squared of 5 degrees. And so far secant squared 5 degrees and secant squared 5 degrees is going to be 0. For problem number 12, the sine of 50 degrees minus the sine over the sine of 40 degrees, you can't cancel or simplify that. But what I'm going to do is keep this as the cotangent of 40 degrees, and I'm going to make this the cosine of 40 degrees divided by the cosine of 40, the sine of 40 degrees, excuse me. So now the cosine of 40 degrees over sine of 40 degrees is going to be cotangent of 40 degrees in the second term. So for our problem, we now have cotangent of 40 degrees minus itself, and cotangent of 40 degrees minus itself is 0. So again, this is cotangent of 40 degrees, this is cotangent as well. For problem number 13, there's really not a lot of room to write this, but I could turn this cosecant of 55 degrees into secant of 35 degrees. So this gives me secant of 35 degrees times secant of 35 degrees, which is the same thing as secant squared of 35 degrees. Then I could turn this tangent 35 and cotangent 35. Since I'm basically making everything in terms of 35 degree angle, I'm going to turn this cotangent of 55 degrees into the tangent of 35 degrees. So now I have secant squared 35 degrees minus tangent squared 35 degrees. And that's equal to 1, because that is kind of a derivation of this, where if I subtract the tangent from both sides, I would get secant squared theta minus tangent squared theta equals 1. So there's my answer to these 4 little identity problems. Now what I'm going to do is I'm going to spend some time solving pieces of this missing right triangle. Now, please understand that this picture in the upper right-hand corner will be the same picture that we're going to use for every single picture, every single drawing that we use. So I'm going to just keep recopying it. So even if I might move past it, please note that every single right triangle will be done from this perspective. Also in the book and in this worksheet, the large capital letters are the angles and the lowercase letters are the sides, and that's pretty universal depending on, I mean, for, you know, going between all the books that I've gone through, usually the uppercase letters were angles and lowercase letters were sides. Also note that the uppercase letters are across from their sides, which is part of the hinge theorem. So for example, the letter B is 10 degrees, and that would mean that this letter B, this lowercase, would be the side across from it. So if you shoot an arrow from the perspective of that angle, it will go to its opposite side, and the letters do share that commonality, C, B, B, A, A, and this right angle is always across from C. All right, so what I need to find is I need to find letter C, I need to find angle A, and I need to find side A. Now the first and the easiest one to find would be my angle A, because 90 degrees and 10 degrees is 100. 100 from 180 degrees is 80 degrees. So 80 degrees is my angle. Now what I will try to find next is I'm going to try to find, let's just take letter A for a moment. And what I'm going to try to do is minimize the amount of work that I could do, or maybe minimize the amount of mistakes I could make. So I'm going to try to find the relationship with A that I was given with the 10 and the 4. So from the 10 degrees, what sides have 4 and A in it? And the answer there would be tangent. So the tangent of 10 degrees is equal to 4 over A, or opposite over adjacent. Now, I'm going to use a cool trick about cross multiplication to get the A in a good place for me to solve for this problem. So you'll notice that I put this over 1 so I could crisscross multiplication, but in fact one of the cool things I can do with any fraction that's equal to another fraction is I can switch the diagonals in their places. This would be equivalent to me dividing both sides by a tangent of 10 degrees and multiplying everything by A. So I can rewrite this problem as A over 1 is equal to 4 over the tangent of 10 degrees. And what this will do is it will give me a very quick answer to A instead of doing all of that work out longhand. Please make sure when you do this problem and you do 4 divided by tangent of 10, that you make sure your calculator is in degree mode. Most of your calculators are set up in radian mode when you start the problem, and you won't understand why you were not getting an answer of 22.69 units in length, even though you had typed in 4 divided by tangent of 10. It's just that you didn't have the problem in degree mode. And now what we will do is we'll take your A, which is 4, your B, which is 4, and your A, which is now 22.69. And you can either use another Pythagorean identity to go between 4 and C. In this case, that would be cosine. And that might be the safest bet, but you can also use Pythagorean theorem. Pythagorean theorem would say that 4 squared plus 22.69 squared is equal to C squared. And then if you solve for C, C will be equal to approximately 23.04. And to talk you through the work for that problem, you would subtract 4 squared, you would actually add all of this together and then take the square root of it. So 4 squared plus 22.69 squared, get the answer, and then take the square root of it would be 23.04. All right, for the next problem, again, we're still using the same picture as up above here. So we have our, in this case, we know angle B, which is 50 degrees instead of 10 degrees. And we know side A in this case, so that would be 7. So we need to find our missing angle and our 2 missing sides. Our missing angle is pretty straightforward. Our missing angle is going to be 40 degrees, because 40 and 50 and 90 make 180. To find our, in this case, let's find side B. To find side B, I'm going to use the relationship between the 50 degrees and the opposite and adjacent, which is going to be tangent. So this is the tangent of 50 degrees is equal to B over 7. Now I won't be using that trick like I did back in problem 14. What I'm going to do instead is I'm going to multiply the 7 times tangent of 50 degrees. So if I do that, I now have 7 tangent of 50 degrees equals B. This is the same thing as cross multiplication if you want to look at it that way, or multiplying everything by 7, getting rid of the 7 on the right hand side and multiplying by 7 here. If I do this out and I multiply 7 times tangent of 50, I get an answer of b being approximately 8.34. And I can use my quadratic formula again, 7 squared plus 8.34 squared, and get my answer for c squared, and then take the square root of both sides. So it's basically adding this together, 7 squared plus 8.34 squared, and then getting an answer, and then square rooting both sides will give me an answer of 10.89 is approximately c. So there's my answer for the problem in 15. I'm going to move this down for the last two problems of this worksheet here. I'm going to move this down for 16 and 17, and that will end our little video demonstration. Okay, so let's get our triangle drawn here. Okay, so there it is. Let's put a right angle there. In this case, we know our side B, which is 6. We know our angle A, which is 20 degrees. And what we're going to find is our angle B, our side C, and also side A. Again, the easiest thing to do here is to find angle B. Angle B is 70 degrees, because 70 degrees, 20 degrees, and 90 degrees equals 180 degrees. Now, if we're going to look at side A, we're going to look at the relationship between the 6 and the A. So that would be tangent again. So here we have tangent of 20 degrees is equal to 6 over A. So this problem is much like number 15, or sorry, like number 14, because, oh, wait a second here, 20, opposite over adjacent. Whoops, I had those backwards. I'm sorry, A over 6. So this problem is like number 15, so I'm going to crisscross multiplication here. You can think of it that way, clearing the denominator. Either way, A is going to be equal to 6 tangent of 20 degrees, which is approximately, using our calculator in degree mode, 2.18. And then using Pythagorean theorem, we can find that C, by going 6 squared plus 2.18 squared, C is going to be approximately, after you take the square root, C is equal to 6.38. You'll always note that the hypotenuse should be the longest of the three side lengths. So it might be good, just to kind of check your answers to make sure you didn't do an addition or subtraction mistake. And note that the largest side will always be the hypotenuse in distance. All right, so our final problem for this worksheet and for this video here, we're going to have a right triangle. We know that the side B is going to be, side A is 6. Angle A is 40 degrees. We don't know side B, we don't know side C, and we don't know angle B. Now, finding angle B, again, easiest part of the problem, because 50 and 40 and 90 make 180, so B is 50 degrees. Then what we're going to do is we're going to actually try to find, let's go try to find side B first. So this is going to be opposite over adjacent, so this is like every other problem on this side of the worksheet. This has been a tangent problem. Now notice I did tangent, let's do tangent of 40 degrees. And the reason why I want to do tangent of 40 is on the very rare chance I screwed up that angle. So if I do this, I go opposite over adjacent, so this is going to be 6 over B. Now in this case I will flip-flop this like we did in problem number 15. So what that's going to make is it's going to make B is equal to 6 divided by tangent of 40 degrees. Now 6 divided by tangent of 40 degrees gives me an answer of approximately 7.15. So B is 7.15. And to find C, C is going to be the square of the two sides added together to find the hypotenuse. So when I add these together, then take the square root, C is approximately 9.33, which makes sense just because I have the longest side now on the hypotenuse. All right, well, thank you for watching this second video for Chapter 4, Section 1 of Trigonometry.